This is Mastering Mathematics with your teacher, Karen Weston.
Hello, welcome again to another in the series of Mastering Mathematics, sponsored by the Ministry of Education Broadcasting Unit and the ABS television station. First thing, what do we observe? We observe that we're going to get 5 marks for this question. So we're not going to spend more than 5 minutes, not 10 minutes on this question. You look, you see what the question is worth. It tells you right away it's something that we should be able to do very quickly. So you're not going to spend your time and then you're going to say I didn't have enough time to finish the exam. So we work within that time frame and within that time limit, not spending more than 5 minutes on a 5 minutes mark question. Anything over, just a little 1 minute, okay? So that's the first thing we have to do. Venn diagram here, I've just drawn it on the side here. We have the set of whole numbers less than 10. And we see our subset A intersect B. And then it says, describe A and B in words. So the first thing, what would we have to say about A? Start saying them in numbers, and we see 2, 4, 6, 8. And in B, we are seeing 6, 3, and 9. Take your time, and we look and we see. It's easy for us to say 2 things would come to our minds immediately. What is it that would come to our minds? We can say, oh, it can be our 2 times table, or it can be even numbers. Which one are we going to say it is? Well, I would suggest to you, don't use the word even numbers, because most of the time we forget that 0 in some of our texts has been described as an even number, and we don't want to go there. We don't want to be in that argument, okay? Because it's easy for you to say that you would have been saying 1, 2, 3, 4, and you would have been saying the first 4 even numbers, and then we could be in a tussle as to whether is that true or is that right. We don't want to be a part of that debate because they tell us in some of our texts that 0 is an even number. So that if you're asking for the first even number, you would be saying not 2, but 0, okay? So we would be on even grounds if we are going to be saying then it is the first 4 multiples of 2 for A. So the set A, we could describe A as the first 4 multiples of 2. So that we can say that is our set, okay? So that A would be equal to that. And B, what would you say that B would be equal to? And we look and we're saying 3, 6, 9. And right away we can say, yes, it is our first 3 multiples for all 3, okay? So here we have 2 tables here. First 3 multiples of 3. All right. Okay, so that's what we're doing here for our first 3 multiples of 3. Now, then it says describe the set in words in relation to A and B. And what do we have? We are listing the members of A intersect B and describing the set in words in relation to B. Intersection, where the 2 sets overlap, that is where we're getting our intersection. And if we had to look on our diagrams up here, we would see that if we were going in this direction, we would see the answer right there. So that we can say that A intersect B is equal to 1 member, and it is just 6. After this, our next question is just asking us to determine and look what you have. N, we see that? N in the A union B complement. When we see this, what are we going to do first of all? We identify what is A union B? And we can say everything here would have been our A union B. And if we talk about the complement, remember we're referring to everything outside of that, all right? And what are the elements or the numbers outside of that? It would be 1, 5, and 7. But nobody has asked to list the members. What are they asking us for? The number. So we have to count and tell them how many members that we have in this set. And the answer, if we are doing that, where we have A in union with B complement, would have been equal to, not in any set, not in anything, but just a number. And the answer is just 3. 1, 2, 3. Please note the difference. They didn't say list the members. As long as you see this little N in front, you know we have to give them a solitary figure in terms of the number of members in the set. All right, so that is one of the questions we can do from set. Then I have a second question stuck away here in the corner. Let's remove this one.
Whenever possible, draw a diagram. Even though you may be able to visualize the situation mentally, a hand-drawn diagram will allow you to label the picture, to add auxiliary lines, and to view the situation from different perspectives.
Now, the second question, the universal set U is given as U is equal to 1, 2, 3, and these dot dot means that the last member is 15. So you must understand that it has 4, 5, 6, 7, 8, 9, 10, 11, 12 as members, okay? Don't say you just saw 1, 2, 3, 13, 14, 15. That is what those dot means. It says you must know that there are also 4, 5, 6, 7, 8, 9, 10, 11, and 12 also as members of that universal set. Then they tell us the sets A and B are subsets of U such that A equal factors of 12, B equal multiples of 3. So once they give you factors of 12, you start writing down what are the factors of 12, okay? And then we would see that the first question is asking us in any case to list the members of set A. So we expect to have curly bracket and each of the items itemized just so that we can see what they look for. In contrast, if they had asked you for the number in A, when we would be counting. So please note the difference in those notations. Okay? So, based on what they have asked for part 1, when they have asked us now to list the members of set A using our universal set here, the factors of 12. And we can start for our factors of 12. I say all the time, you know your first number, you know your last number. Because 1 and the number itself is always a factor. All right? So we start fitting. And we can say, is 2 a factor? Yes. What about 3? Yes. What about 4? Yes. Is 5? No. What about 6? Yes. And our last factor would have been the number 12. Okay? So that is what we can say. Start with right around. And then B, using this particular setup here, they want us to give them multiples of 3. All right? So we would have B then would have been equal to, and from this set, yes, we would have been getting 3. We would have been getting 6. We would have been getting 9. We would have been getting 12. And we would have been getting 15. Okay? Do not go outside the universal set. Universal set refers to this particular question, and it stays within that. Only the numbers in here you are using. So don't say 27. No. Universal set ends at 15, and that is where we stay. Okay? So these are the multiples of 3. Now it says represents the set A and B and U on a Venn diagram. And here, Venn diagram, what word is that? Yes, a Venn diagram is made up of a rectangle, and circles. They've given us 2 subsets, so we know right away we're going to have 2 circles. We look first of all at the members we have listed. So because we want to say, are we going to have a disjoint set where they don't meet at all, or are the 2 subsets going to intersect? And what would determine that? We look at the members and we can see that they do have some in common, because I am seeing, you can see 3 with 3, we can see 6 with 6, and we can see 12 and 12. And where would we be placing those? In the intersection. In the intersection. So now we can go ahead and draw the subsets, okay? So we know that they are not disjointed sets, they intersect and they have members in common, okay? So if we have A and we have B, all right, so right away, and when we have common elements, we write them once. So we have 3, you have 6, and you have 12. All right, then we go back to set A and we start looking and saying, what are the other members of A? And we have 1, we have 2, we have 4, and that is it, because the other members are in intersection with the members we would have been getting from B. So again, now we go back to set B and look and see what are the members that we did not list. And then we look and see there is 9 and there is also 15. Okay, we put up our universal set and we're looking and saying everybody needs a house, everybody needs a shelter. And for the other members, they are not a part of set A, they are not a part of set B, but they are a part of the universal set, so they would be occupying the space out in the rectangle. So who are these people? Because we have 1, 2, 3, 4. We don't have 5, so 5 has to be here. We have 6. We don't have 7. 7 has to be here. We don't have 8. 8 has to be here. 9. We don't have 10. 10 has to be out here. Then we look again and 11 has to be out here. 12 is there. We don't have 13. Neither do we have 14. And that is how we place the other members. Okay? So the members that are not in the universal, that are not in the subsets, but are part of the universal set, would be outside in the rectangle. Then the last part of the question has asked us to list the members of A union B complement. A union B complement would be equal to, again we use our definition, the complement would involve everything outside of A union B. So once we can identify the areas for A union B, which we would know would be all this, we know right away that anything outside of this area would be our complement. And so we start writing them. By convention, we like to start from the small number, so we'd be going 5, 7, 8, 10, 11, 13, and 14. Does not mean that somebody could have written 7 and then write 10 and write 14 and write thing. You'd still have gotten your mark. All right? And this question, again, I'm sure will be worth about 5 marks for anything like this. And again, we have to practice, practice, practice. And I am going to show you a different one this time, because we will also be getting describe using set notation the shaded region in each Venn diagram below. So I'll be drawing them one on one just to save some time and then ask for our questions right away. So the first part of this, and hear what CXC has done. For this particular